2 weeks ago when I was on board the ship, we had my friend Kate help out. We found some really easy supplies on the ship, and we did a really quick and easy experiment together. So I'm going to turn the volume down here, and I'm just going to talk about this experiment. And so what we did is we took some water in a bowl, we took some dish soap, and we took some pepper. And so what we did is we sprinkled the pepper on the surface of the water. So a big shout out to the cook on board who gave us some supplies that we could use in our experiment. So we sprinkled the pepper on top of the water. And after we did that, Kate put some dish soap on her finger and she dipped it into the pepper, and we got to see what happened. Now, unfortunately, connectivity on the ship can be kind of hit and miss, and we didn't see this happen fully in real time. So you see Kate's got the soap on, and then I think we had a small pause just as she dipped her finger in, but we saw the results. When it unfroze, we saw that the pepper sank. We saw that the pepper had shot across to the other side of the bowl. So there's a few things we need to talk about here as to what was happening. So let me pause the video here and let me talk a little bit about what we saw happen here. So first of all, you saw that the pepper floated. Why did the pepper float? Well, it's less dense than water. So anything that's less dense than water, it will float on the surface. The next thing you might have thought, well, why didn't it dissolve? We have had experiments in the past where we've put baking soda in water, we've put sugar in water, we've put salt in water, and it always disappears. But the pepper didn't do that. It didn't dissolve. That's because pepper is hydrophobic. That's a fancy way of saying that water's not attracted to it. So because it's hydrophobic, the water doesn't dissolve it the same way as it does with something like baking soda or sugar or salt. So what happened? Why did it react to the soap the way it did? So water has something called surface tension. Water molecules like to stick together. If you have time today, fill a glass with water in your classroom and then slowly keep adding drops of water. And what you'll see happen if you do it nice and slow, you'll see a dome of water form sticking out over the top of your glass. Eventually you'll get too far and it will break the surface tension, but water molecules are really attracted to each other and they tend to stick together. But when we add the soap breaks the surface tension of the water. That's why soap is such a good cleaner. It can break the surface tension of water. So we saw the pepper shoot to the sides because the water wanted to get away from the soap and it wanted to try and keep its surface tension. So that's why the pepper shot to the sides and you saw the pepper sink immediately. That's because in the center of the dish, the surface tension was broken and the pepper was able to sink to the bottom. And then the water shot to the sides to try and get away from the soap and keep its surface tension. And that caused the pepper to go along with it and shoot to the sides. So that was our surface tension experiment.